In the last video, we looked at characteristics based on degree, number of terms, and so forth. In this video, we're going to take it one step further, and we're going to look at end behavior. So in order to look at end behavior, we could put all these things in our calculator and for the sketch, but for the sake of this video, I want to teach you some concepts. So the first thing that we need to look at is what type of function do we have. So when I look at the first one, I see that it is a fourth degree function. This means that it is even. So with an even function, I know that the ends go in the same direction. The other thing that I want to look at is I want to see, is this a lead coefficient, is this positive or negative? So my lead coefficient here is 1, and 1 is positive. So what does this mean for my sketch? It means ends go in the same direction. So this means ends go in the same direction, and the positive lead coefficient means that they both go up. Okay? So that means when I sketch this, both ends go up, and I'm going to have something that probably looks a little bit like this. That's just a guess. These turns in the middle is just a guess. So we'll talk about turns in the next video. So let's talk about end behavior. So when we're talking about end behavior, we're really talking about what's happening on the left side and what's happening on the right side. So there's a way that we use notation. So the left side, we usually say as x goes to negative infinity. So that would be our left side. What's happening to the function? Well, the function is going up. On the left, it's going up. So that means we're looking at now what does our output do? So our output is our y. So we say f at x is going up. Up is at infinity. Okay, our whole function is going up. So the right side would be this side, so that's where as x goes to positive infinity, that's our right side. Which way is our function going? Our function is also going up. So that way we're going to say our function is also going up, which is infinity. So underneath here I'm going to write up and up. And again, we could put that in our calculator and see what the end behavior is. Let's look at this next one. So the first thing we want to notice is what is our highest degree. Our highest degree is 2. That means it's even. So that means that the ends go in the same direction. The next thing we're going to look at is this a positive or negative lead coefficient. So when we look here, this here is negative. So negative means it goes down. So our ends go in the same direction and they're both going down. That means I have an end going down and an end going down. This is a quadratic, so it's going to look something like this. Oh, I need to write here negative. Forgot to put that in. So if you notice, I'm color coding this so you can see what I'm talking about with the colors. Okay, so let's talk about left and right. So here on my left, my function is going down. And on my right, my function is also going down. Okay, so if I want to say the left side, I'm going to say as x goes to negative infinity, what's my function doing? My function is going down, so that would be negative infinity. So again, this is my left side, and this is my function is going down. Now let's look at the right side. As x is going to the right, so that's my right. Where's my function going? Well, my function is going down. So that would be negative infinity. Negative infinity for the function is down. Okay? Okay, so those were even functions. Let's look at this next one. First thing I'm going to do is I'm going to look at the degree. 3. This is a third degree. This is an odd function because 3 is odd. So that means that the ends go in opposite directions. Ends go in opposite directions. Let's look at the lead coefficient. Well, the lead coefficient is positive. It is a 1. So I'm going to write positive. So we want to think of this as, now I'm putting this in quotes because we don't literally have a slope, but we're going to think of this as a positive slope. Okay, going back to linear functions, because remember, a linear function is also odd. So if I were going to do a positive slope, it would be something that looks like this. So that means that I'm going to have, this is going up and this is going down. So you notice my arrows are not necessarily going in the same direction of that line. So it's odd. So my odd degree functions look something like this. That green line is just for me to know where my endpoints go. So again, let's talk about end behavior. So this is my left side, and this here is my right side. So if I want to say the left side, I would say as x goes to negative infinity. So as x is going out this way, where's my function going? My function is going down. So that would be that my function is going down to negative infinity. So here, the left side of the function is going down. That's what that means. So the right side would be, as x goes to positive infinity, what's my function doing? My function is going up. So to say it's going up, my function is going to positive infinity. Okay, so this is my right, and this is up. So let's look at our very last one. My very last example, again, I'm going to look at the degree, 5. 5 is odd. So that means that I meant to make this should say negative. I want to make this negative. So make sure you show me that that's a negative function. So here, my ends go in opposite direction. They go in opposite directions. And because this lead coefficient here that I just corrected is negative, so we have odd and negative, that means we have a negative slope. And again, I'm putting this in quotations because this literally does not have a slope. So it has a negative slope. That's just a concept. Negative goes this way, okay? So that means this side is going to go up and this side is going to go down, and I have something like this. Okay, so this again, this is my left side. So for left side, I say as x goes to negative infinity, where is my function going? Well, on the left side, my function is going up. So in order to say it's going up, it's going to positive infinity. So here, this here is my left side, and it's going up. Now we need to look at the other side, the right. So this is the right side, and my function is going down. So as x goes to positive infinity, f of x, or my function, is going down, which is negative infinity. So again, this is right, and this is down. So that's how you decide end behavior, simply looking at what the characteristics of your function is.